Okay, so I was in Costco. I found this really good good deal on a 75-inch TV. Okay, but I was worried about not being able to get it out. Okay, so the box was bigger than the TV itself. Okay, which you can kind of see in the picture, right? You can see the TV itself. Like, to measure TVs is always measured on the diagonal from corner to corner, right? And so you're getting a 75-inch TV from corner to corner. Okay, that's how you measure TVs. Okay, but the dimensions of the box were like bigger than that. Okay, so my question was to myself, could I get this out? Like, could I get it home after I bought it, right? I didn't want to spend whatever amount of money on a TV, get it outside, and not be able to get it home, because that wouldn't be very good. Okay, so anyway, that's the dimensions of the TV. On the right side are the dimensions of the vehicle. Okay, and so our back opening is like 26 inches tall and 34 inches wide. Okay, and you can also see here the distance to the seats, like depth wise, this way into the kind of to the seats is 80 inches. Okay, it's not a small vehicle, but nothing. It's not really meant for like moving big things like sheets of drywall and things like that either, right? So there are some limitations of owning this thing. So I guess one of my questions was, even if I could get it in there, am I going to be able to close the hatch so it doesn't fall out? Does the box even fit into the back of the vehicle? Okay. So just in looking at this, it doesn't appear that right now, like, I'm going to be able to stand this box up in here, right? It's not going to fit. Even widthwise, even if I laid it down, that's not going to fit widthwise here either, right? And so I'm like trying to do some math here, and I'm like looking at this, and what I see, if you guys, and maybe some of you are like, okay, well, could you lay it this way? Would it fit in on the diagonal? Right? That's my initial thought, right? So I'm like, okay, well, how big is that diagonal, right? Because you got to make the decision, right? So I'm going to come down here, and we're like, okay, well, does the box even fit in the back of my vehicle, right? So let's do the math here. So we've got kind of a triangle, right? Here, I'll draw it the other way because that's the way I had it in the picture, but I'll draw the back, and then I'll draw in red what I'm worried about, okay? So my thought is, can I tilt the box on its kind of side such that it like fits in here like this? Okay, does it fit? Right, and we know what the dimensions are. It's 34 inches wide, right? And then also 26 tall. Okay, so our question is, okay, can I lay the box this way? Okay, so I don't know. I guess our question is at this point, what is this length? Right, like, how long is this? Okay, that's our question. So it turns out that there's a way to do this, and it's called, I think you guys would have done this. It's called Pythagorean Theorem. Okay, this is just an example. Like, trig's pretty applicable to real life, actually. Like, a lot of the careers that you guys are going to get into, like, trig is everywhere. You can use this a lot. And even like stumbling around in your real life, you start to run into it. Like, this is a perfect example of somewhere that, you go in expecting to be able to do something, and you can't. You look at it and you don't know. You end up using some math to figure it out, right? So we have this thing called Pythagorean Theorem, and what it says is, it's like, I'll do it a different color because this is an important thing. It says that a squared plus b squared has to equal c squared. Okay. Can anybody in the chat right now just say if you've seen this before, just out of curiosity, because it's going to dictate how much work I do here as to what this is. Have you guys ever seen this? I'm going to take silence as a no. Okay.
Both Jude and Evan say they have.
What's that?
So both Jude and Evan say they've seen it.
Why am I not getting updates in my chat? That's kind of weird.
No, that's what I thought. Ethan says he's seen it too.
Okay. All right. So I'm not getting updates in my chat. Okay. So anyway, okay. I'll just like briefly go through this. So if we here's what happens. Okay. I basically have a little, like, that red triangle is a triangle, right? And so if I were to label triangles, I don't know if we explicitly did this morning, but if I were to label the triangles, there's going to be a 90 degree down there, okay? And then the way that I would, like, those are the angles labeled currently, right? That's angle A, that's angle B, and this is angle C, where angle C is 90 degrees, right? Well, when you label a triangle, you can also label the side lengths, right? And the way that works is the side length gets labeled by little letters instead of the capitals, right? So opposite of capital A is going to be, here, I'll do this in a different color, little a, okay? Opposite of capital B or angle B is going to be side length B, and opposite of angle C is going to be side length C. Okay? Now, that's just, if you look, side length A is opposite of angle A, B is opposite of B, and C is opposite of C, okay? So, when I look at my equation for Pythagorean theorem, it's not talking about, and this is a common mistake that people make, it's not talking about the angles. That would be talking about the angles. It's not talking about the angles. We're strictly talking about the side lengths when talking about Pythagorean theorem, okay? Well, it turns out that I'm able to find a third side length using this equation if I know two of the others. In this particular question, I'm looking for C, and I know A, and I know B. So what you guys can do is you can plug in the values into the equation for A and B, and then do the math, okay? And what it's going to do is, I'm just going to do it. A is going to be 26, plus B is going to be 34. That has to equal C squared. So we do the math on that, okay? So we get to go 26 times 26 equals 676. Okay, plus 34 times 34. Okay, then you just add those two together. Okay, you're like 1156 plus 676. Oops, 1832 equals C squared. Okay, some of you might be thinking at this point, right? You're like, okay, Mr. Guy's standing in the store, right? Why doesn't he just run out to the car and measure, like take his tape measure and measure from here to here, right? Well, two reasons. One, I was inside the store. Two, I didn't have a tape measure. Okay, but I've moved stuff in the past, right? Vertical stuff that I knew what kind of, I knew it was like 26 and 34. Okay. So I'm thinking, okay, I'm standing in the store and I'm trying to figure out, okay, can I lay this thing diagonal? Because obviously I know it's not going to stand up or lay down on its back, right? So I'm like, okay, can I just stand it, like lay it on its angle? So it appears right now that, yeah, no problem, right? But there's one more thing that we have to do here in order to actually get C, okay? And it involves, if you guys see this little squared, you're thinking, okay, well, squared, I don't technically, I suppose, if you're thinking about this mathematically, you technically, and we saw this, C times C. This is what's gone on here, okay? You technically don't have C by itself, right? You still have two C's there. Well, the way to deal with this is you can what we call square root. Square root is opposite of squaring something. Okay, so but what I do to one side, I have to do to the other. Right? And so we're going to say the square root of 1832 is equal to C. Right? And so you do the math. Oh, can I do it on here? Yes, I can. Okay. So 1832, your square root looks something like this. Okay, it's got like a little hook on it, right? You're like, okay. C is equal to 42.8 inches. Right? Okay, so now you know how far or how long this is. Right? Now you go back to the question. You're like, okay, we're standing in the store. I think what it was is the employee had a tape measure, but he wouldn't let me take it out. Right? And so I'm like thinking, okay, how do I do this? So he measured, that's how I got some of this. I think he measured some of it, right? So your question is, okay, I'm going to like reorientate the box, right? So when I go to like, I'm going to try and slide it into the back of my vehicle, and it's going to look something like this, right? And so can I lay it diagonally on its side to fit it in there, right? Well, it turns out that the height of the box was 44 inches, right? So now I'm like, okay, I can't get it in, right? So then my next question is, okay, well, what if I took it out of the box, right? Now I'm sitting here trying to do all this stuff in my head, right? Right? Because I also don't know how tall it was in the box. And I wasn't going to buy it and take it out. I wasn't going to buy it, take it outside, find out that 44 inches was bigger than the 42.8 that I measured, right? And then be stuck in the parking lot with this 75-inch TV in the box, and then have to figure out, okay, well, if I took it out of the box and risk damaging it, could I fit it into the back, right? And it's not a light thing either. It's pretty heavy. So this is just one example of like me doing some math, and you guys will probably do this at some point too, where you're like, you're stuck in a pinch and you're trying to figure out, you've seen triangles if you're looking for them, right? So it turns out like we ended up ordering the TV, right? And it ended up getting delivered. No problems. But let's just suppose for a second, because I didn't want to take the risk of opening the box in the middle of the parking lot and trying to slide it in there. I just wanted to figure out, maybe I could have done that, right? And so my question is, okay, I know how tall it is, right? Because the employee measured it this and this for me, right? But what if I could measure, like, if it was out of the box per se, maybe once I got it home, I could take some different measurements. But with what I had here, could I figure out how long the box was? I mean, I suppose I could have measured it too, but I'm just trying to create a math question for you guys. Okay. So remember what I said over here, right? Like the depth of this box really affects how far into the vehicle I can get it, right? I don't know if I can get it all the way in there. So what if I did the same math here and figure out whether or not this is going to fit into the vehicle? All right, well, let's figure that out, okay? Because what you have, we just finished talking about how if you have two side lengths, you can find the third. Okay, so you can use Pythagorean Theorem, set it up, right? You're like, okay, a squared. Okay, now here's the catch. You'll notice the way that I've written or drawn the triangle down here. Okay, C is always what we call a special word. I'm just uncovering things as we go here, okay? This right here, this diagonal that you see, that you guys see, this has a special name. Does anybody know what it's called? Instead of curiosity, you can turn your mic on and yell it out, but if you know what it's called. It has a special name, okay? These two here are just side lengths. There's nothing too fancy, right? A and B. This one here has a special name, and I'm sure you've heard this before. It's what we call the hypotenuse, and I think that's how you spell it. Unless it's... I always have a hard time spelling this one. No, that's not right. I think I had it right. Okay. Okay, the hypotenuse is always, by definition, the longest side. Okay, in a triangle. Okay, so you're always going to label or put the hypotenuse in the C position. Okay, it's always going to be there, whatever that number is. Okay, so if I were to draw this triangle down here, right, the TV, I'm going to draw the triangle. I'm going to say, okay, oops. You're going to say, okay, 44 inches, 81 always goes on the diagonal or the hypotenuse, right? And you're trying to figure out what this is. We could call it B. This is A, and this is C. All right. What a lot of students like to do is they just want to put the 81 in here and make the math really easy, and the 44 in here, and just figure out what C is. That doesn't work. Okay. C always has to be the hypotenuse. Okay. So you just plug the numbers in just like last time. So there's a catch this time. Okay. So A, and it doesn't matter if A is 44 or B could be 44. That part doesn't matter. What matters is C always has to be 81. Okay. That's what matters. So I'm just going to plug the numbers in. 44 squared. Plus, I don't know what B is, so I'm going to leave it B. B squared is equal to 81 squared. Okay, this time you're not solving for B or for C because you know what C is from the picture, right? It's 81 inches. So you're like, okay, I got to solve for the other one. What does B represent in this question? Well, it represents the depth of this box. Like when I go to push it into my vehicle, is it going to hit the seats or not? And am I going to be able to close the hatch? Right? Is the question. Right? So we're like, okay, well, let's figure out what B is. Right? So the way to do that is you can like just isolate like normal. Right? So you're like, okay, well, you can do the math first if you'd like. We can do that if you'd like. Let's do that. Okay, we'll just get numbers. 44 times 44. That's what it means to be squared, right? We talked about that. 44 squared is the same thing as going 44 times 44, right? There's just two 44s, right? Multiplied against each other is the important part. And we get 1936 plus B squared equals, and then you can do the math on 81 squared. 6,561. Okay, give me B by itself. So you can subtract. Subtract 1936 from both sides. Okay, and you're going to be left with, okay, B squared is equal to 6,561 minus 1936. Okay, minus 1936. B squared is equal to 4,625. Okay, well, this seems astronomical. Like that seems huge relative to 44 and 81. So it's at this point that you're recognizing the fact that, okay, it's too big. So I'm going to have to like do one more step, right? That one more step is square root. Okay. Okay. So anyway, long story short, I got the thing home and I figured out, I took it out of the box and I took some measurements. Turns out that the likelihood of me being able to fit it into the back of the car out of the box probably would have been pretty high. Okay, I probably could have gotten it in there because you can see diagonally the TV is like there's a lot of padding in this box, right? There's probably a significant amount of styrofoam around the perimeter of this thing, right? Like I'll do it in I'd probably say most of this all in here is padding, styrofoam of some sort, right? And so when you get it home, for me to figure out whether or not it would have fit, it would have to be smaller than 44 inches because of the box, right? I would have taken it out of the box. And the likelihood of it being less than 42.8, because that's what we said this was pretty high, right? You guys see that? Right? This was the 42.8. Right? So it would have fit on the diagonal, but the other piece would have like, okay, well, I don't know is it too long to fit behind the seats? So like, could I have closed the hatch on it? Well, it turns out that the distance to the seats is 80 inches, right? And I figured out that the TV itself, right, or at least the box would have fit in there no problem because it was 68 inches, right? So the TV itself would have been less than 68 inches, probably, I don't know, it could have been probably even 62, right, or 64 inches. So I had lots of room to slide it in there. Had I taken it out of the box, it would have fit. But that's not a decision I wanted to make after spending the money and being in Costco's parking lot, right? You can see, like, I'm trying to figure out all this in the store before I buy the thing and then get it outside and not be able to take it home, right? That seemed like a good question. I think that's a okay question. This is just one example of where I've used trig in my real life, right? Where like I'm in the store trying to spend some money and you don't want to spend that money and not be able to get the thing home, right? That's not a good situation to be in. Okay. At the same time, I try to introduce to you guys this notion of Pythagorean theorem. Okay, so I'm just going to write it down here one more time, just to clean it all up. This is the point of today's lesson. Oh my goodness. Okay. What do we use this for? We use it for solving for okay, when does it work? It only works when you have a 90-degree triangle. What does that mean? It means you have a triangle that has a right angle in it. Okay? This is the point of today's lesson. You'll see in Minds Online, you have, I don't know, 5 or 6 questions with some like Pythagorean theorem questions. Okay? The golden rule for those questions is, can you use this? Okay? That's all that matters. Okay? And then applying it to certain situations, right? Okay, does anybody have any questions? I can't see the chat for whatever reason. I don't know why. Maybe it just doesn't come up when I'm presenting my screen. I don't know what the deal is, but anyway, we're gonna do a few scenarios like this where I've like used trig in particular in real life, and hopefully that conveys an importance of, I don't know. Trig is actually pretty applicable to real life, which is kind of fun. Okay, not that the other stuff I haven't shown you isn't. You have to look a little bit harder. Okay, this stuff is very abundant. You run into this stuff, trig in general. All the stuff that I'm going to show you in this unit pops up all the time. Okay.